Hello and welcome back to Azure Terraformer. Just got back from HashiConf and it was a blast. It was a really great show. HashiCorp is extremely generous to all of the attendees with prolific amounts of snacks and beverages and happy hours and like parties. You know, it was a great time. It was a great time. I spent a lot of time manning the booth. I got my certification done for Terraform Associate. Got to put a lot of faces to names and get more plugged into the community, which was a lot of fun. You know, here it comes. I've had some time to sit down and put my thoughts together, and you know, I'll be kind of reviewing some of the announcements and some of the new technologies and new features that are coming out that were announced at the conference. So stay tuned here on Azure Terraformer. Today, I'm going to look at the day one keynote of Armon, where he talks about Terraform. We're going to zoom in on Terraform a little bit here and just give you the highlights of the day one keynote. So here we go.
Discover it through cloud provisioning, right? Starts off by, hey, I need to set up my Google or Azure or Amazon accounts. That tends to be where people start. From there, what we see is people start to apply it all over the place. So why can't I use it to manage my networking configuration in a private data center? Why can't I set up my vSphere and OpenStack and on-premise environments or even bare metal? And then all the way up to high-level software as a service. So for example, with HashiCorp, we even manage our Okta environment and our Datadog environment and our GitHub environment, which are all SaaS as code using Terraform.
This is an often neglected point. Terraform does more than EC2 instances.
And so these are all immensely popular use cases, and you can go see things like the Okta provider, which has 10 million downloads on the public registry.
Or the Grafana provider, or the Azure DevOps provider, or the Azure Active Directory provider.
So as you can imagine, we've been incredibly busy in the Terraform space. I'm certainly not even going to scratch the surface of some of these things, but I do want to highlight a bunch of really exciting announcements that we have coming. So first is when we think about kind of module testing in Terraform. For a long time, there was no native way to actually do any sort of testing. So
really, the only native way to do testing was to set up transient environments using randomized naming, things like that. Run Terraform apply, make sure your module worked, right? This is very tedious. Now, I have not done a fully exhaustive review of the new test capabilities built into Terraform. That's definitely on my to-do list. But having done a lot of Terraform testing previously, I can attest it is a very difficult and grueling process. But I think that's kind of the nature of the way and where Terraform sits within the ecosystem. It is a middleman between these different cloud platforms, right? It's not, a traditional programming platform like .NET or Java or Python. You can't even begin to compare it to those things. Testing is inherently difficult with Terraform. I suspect I'm going to be a bit underwhelmed with the testing capabilities. However, that's not a knock on Terraform and Terraform testing. I think it's just, there's really no good solutions right now without, actually running a Terraform apply against the target platform that you're provisioning against.
As module authors, we'd write these modules, our application teams would consume them. But if there was any issues with it, right, a user either misconfigured it, the module was poorly behaved, there was edge cases that weren't handled, you'd end up with the app basically breaking.
And this is why I think it's important that modules are very opinionated and have very discrete contracts with the end user. Too many modules try and be everything to everybody, meaning one module can be multimodal, and it basically is trying to solve all the world's problems. It has huge amounts of inputs, and there's like an infinite different ways that you can use that module. I think the best way to use modules in the most consistently to breed consistency within your cloud architectures is to create very focused modules that implement very specific and very opinionated success patterns of deploying architectures.
Now you have to go debug this thing because, there was an edge case that was not well tested.
You really can't debug Terraform, right? And I think this is one of those things that Terraform Test brings in from some of the conversations that I've had with people that have touched it, is, maybe there's some ways that you can actually run intermediate values, like calculate locals and things like that, much easier than before. But evaluating locals is, not debugging. It's not the same thing at all. So that, again, this is why it's really important to keep your Terraform code really clean and really focused, so that you don't have really nasty, gnarly code implementations in there that you almost need to dissect in order to figure out what the heck it's doing.
So we've seen this problem, and I think since basically the dawn of Terraform, there's been an ask for, okay, but how do we do better and more native testing? And so with Terraform 1.6, we added exactly that. We brought a native test framework. Terraform 1.6 was available late last week.
1.6 also breaks compatibility with the last quote-unquote open source capital O, capital S version of Terraform, 1.5.5. Interesting timing. Trust me, you know where I stand on this issue. I think it's totally fine. I think it makes sense. I hope HashiCorp makes a lot of money.
And so what this now allows us to do is, as part of our module definitions, we can define inline tests in a way that's native to Terraform, native to HCL. And now we can make sure that that behavior is well validated, well tested, so that our application developers have a great experience, right?
I really would like to unpack what he means by the word well. So again, I'm going to be working with the test framework within Terraform, and trying to unpack what well really means. What well tested can we achieve using this framework? So more to come on that one for sure.
These modules are well tested, edge cases are handled, the behavior is as they expect, right? In addition to that being part of the core Terraform definition, it's also a part of Terraform Cloud and Terraform Enterprise. So as we explore the various modules, we can actually drill in and say, okay, great, I can see that there's multiple tests defined, but this module is actually failing its tests, right? So this can, as we start building a shared set of internal modules.
It's interesting that the .hcl file extension has been introduced for Terraform tests. I asked somebody at the conference, because I noticed this with Packer HCL. The extension for Packer HCL is pkr.hcl. I was curious if they're ever going to make the move to tf.hcl. There was really no commitment on that whatsoever. But I don't know, like the just all these extra extensions, like the 2-part extension, file extension, just makes, it's a little bit exhausting for me. But I understand that especially as we see more different types of files within Terraform working directories, .tf alone is not going to cut it unless, something changes. So I understand why they're introducing these file extensions. It just kind of gives me a little bit of a headache.
We also want to provide confidence to people that, yeah, great, not only are there tests, but they're all passing on a regular basis as well. So this is all part of how we provide that kind of day 2, day 3 full lifecycle management and manage this stuff at scale, because it's rarely one and done with a module. Now, obviously, no keynote would be complete without some discussion of AI.
Yada, yada, yada. You can use ChatGPT to generate Terraform tests. I'm going to skip this. It seems like it's something they built into Terraform Cloud. I'm a huge user of ChatGPT. I love it. Use it all the time. Helps me solve problems. Just like everybody, like you can't rely on it to do the thinking for you. It is a tool that, when combined with human intelligence, can produce some pretty cool stuff. It doesn't get it right, 100% ever, unless it's like a really simple use case. But I think it's great that, they're doing what everybody should be doing, which is thinking about how ChatGPT and technologies like it can be embedded and add value to whatever user experience you're developing. So hats off to them for that. Let's skip on ahead.
A few moments later.
One of the things we've always seen with Terraform is there's a need to do multiple workspaces as you get to more advanced configuration.
Basically, what happens when you have multiple providers that provision at different layers of your architecture? A great example of this is running Kubernetes. Oftentimes, when you provision a Kubernetes cluster, you're doing that at the control plane of the cloud platform, i.e., you're provisioning to Amazon's REST API using EKS, or you're provisioning to Azure's REST API, and you're provisioning AKS. And then once that is done, you need to provision to your Kubernetes cluster using the Kubernetes REST API, using like a Kubernetes provider or a Helm provider or kubectl, something like that, right? That deploys your YAML manifests. So the idea is that we've got multiple control planes that we're trying to hit, and we need to orchestrate across those. This is something that we all do. We typically break this apart into different Terraform apply steps. So, you've got a different workspace for, whatever you provision to Azure. Then you got a different workspace for whatever you provision to Kubernetes. And then you have to kind of pipe them together. You have to take the Terraform outputs that have the connection details for your Kubernetes cluster, and you have to pipe that into, the Terraform that's going to be, provisioning services and deployments to your AKS cluster. Pretty standard stuff. Now, the reason why you have to do that is because when Terraform runs a plan, they want it to be deterministic. And you can't really be deterministic if half of what you want to provision is dependent on something within your code, i.e. that AKS cluster. Basically, what the problem becomes is you have to run Terraform apply twice, if it's all within one solution. You have to run Terraform apply and just get past, provisioning the AKS cluster, and then you run Terraform apply again, because you can't really initialize the Kubernetes provider until that AKS cluster is there, which has the authentication, and that AKS cluster is live, to inform the Kubernetes provider how to talk to that AKS cluster. So you either are stuck between two kind of bad options. One option is, you have everything in one Terraform workspace, and you do targeted Terraform applies, like I just described. Or the other option is you break it up into two Terraform applies, one that just does, everything on Azure, and then the next one that does everything on Kubernetes. So apparently, Terraform Stacks solves this problem.
Right. So if I take a relatively simplistic app, you might say I have an underlying infrastructure. Maybe I'm bringing up core networks, VPCs, et cetera. Then I have a Kubernetes app that's going to layer on top of that. And then I have three environments, right? Dev, test, prod. In that sort of a very classic kind of a setup, I would have multiple configurations, one for my underlying, one for my Kubernetes app. I'd have multiple environments. And so this translates to many different workspaces, right? So I have workspaces for each of these configurations / environment combinations. And now I have to orchestrate manually across all of this. I have to first run it across dev, test, prod, bring up my underlying infrastructure, then go and orchestrate the application deploy across all those things. So of course we can do this, and we have users that have many thousands of workspaces and very complex topologies. But we constantly been looking and saying, how can we make this better? How can we automate this more? How can we bring more awareness to Terraform of the fact that there's dependencies between all of these different workspaces? So what I'm super excited to preview for the first time today is what we're calling Terraform Stacks. And what Terraform Stacks does is bring a native understanding to Terraform of multiple component layers, multiple environments, and provide a single orchestration experience across all of it. This is the biggest enhancement to the Terraform orchestration engine since Terraform was released.
So Terraform Stacks basically is canonizing this process of separating, based on provider, layers within your Terraform codebase so that you can run multiple Terraform applies. This allows each Terraform apply to be deterministic, meaning everything within one Terraform apply is has all of its dependencies met, and we can do a full plan. And it kind of creates top-level language structures that describe these boundaries within our stack, I suppose.
And so what this lets us do is have a single configuration that spans multiple configs, right? Could be our underlying network config as well as our Kubernetes app and multiple environments, dev, test, prod, and capture all of that as a single stack. And so now when we interact with Terraform, it can actually do that orchestration across all those components and all those environments as part of a single workflow, rather than requiring you to stitch together sort of a workflow across multiple environments, multiple components.
Which is pretty much what I do all the time, using either Azure DevOps or GitHub Actions. You create a pipeline and you have to stitch these layers of your architecture together in order to get them to work. Now, this sort of function, I think, still happens. You're still going to have blast radius around, your application team and your platform team, because I think your platform team will have their own stacks, where they layer architecture on top of other architecture, and maintain blast radius within their own stacks. And then application teams may also have their own stacks, where they build on top of whatever the platform teams have developed. But this is huge. I mean, we have 2 new language constructs. Historically we have resources, we have data sources, we have modules. But beyond that, now we have these things called components. And a component is essentially, I like the term, I think I often think about it the same way. It's a component of your architecture. And these components are basically describing that layer of your architecture. So if your layer is the Azure infrastructure, that's one component. And then if you have another layer, which is your Kubernetes, configuration, that's another layer, your stack, which is manifests as a component. Now, the next concept that they introduce is a deployment. Now, a deployment is kind of like a workspace is today. A deployment is an instance of a component. So I might have, this stack that I provision dev, test, and prod. And in the dev instance of the stack, I'm going to have my infrastructure component and my Kubernetes component. Each instance of that component, that infrastructure component, is going to be a deployment. So I've got a deployment of that component for dev that sets up my AKS cluster for dev. And then likewise in test, I'm going to have an instance of that component, i.e. the deployment, in test, which is going to be that instance of the Kubernetes cluster out on Azure. So components encapsulate basically a blast radius, of a Terraform workspace that is fully deterministic. And then a deployment is an instance of that thing provisioned out that usually ties to your application lifecycle, dev, test, prod, or potentially a region, hey, east, west, central, north, central, etc. So very interesting, way of kind of solving this problem. Honestly, I'm pretty excited about it. I think it's going to get rid of a lot of the plumbing and glue that I tend to have to put into my pipelines to kind of stitch everything together. So I'm very excited.
Now, this is meant to be a relatively simplistic example. The opportunities of what this solves is actually a bunch of different things that we've heard from users, right? One is, what if I have a very complicated set of dependencies between multiple layers of components? I want to bring up networks, storage, databases, different security layers, app layers, all at the same time. So I might have many, many different layers of components that are required to bring up. And great, we can orchestrate across all those. The other thing we've heard is, well, what about more complex environments? I don't necessarily just have a single production. I might have prod that spans multiple regions, US, EU, et cetera. And I might want to do staged rollouts across them in a phased way. I don't want to just big bang it into production. And so all of those things now become possible with stacks. You can model these different deployments in as fine-grained a way as you want, as well as the components in as fine-grained way as you want. And then the stacks allow us to orchestrate across all of that. So I don't want to take too much thunder. Right after the keynote, you're going to hear from Harold, and he's going to do a deep dive on stacks and some of the upcoming capabilities around it. But I'm super, super excited about this capability. Next, I want to talk about ephemeral workspaces. We announced this capability over summer. And I think the challenge we've seen over and over again is you have development and testing environments where resources are left running for way too long, right? We brought something up for a CI run. It only needed to run for a few hours. And then, oops, we forgot about it. And 6 months later, we're still paying for it.
I love this idea. I've implemented similar solutions using Azure Functions and like a tagging scheme, which basically says, look, if you're in the subscription and you don't have this tag, I'm going to delete you. And if you're in the subscription and you have this tag or this set of tags, those tags are going to inform when I delete you. And it's kind of up to you to update those tags, with, hey, stay alive, keep alive. And so I think this is kind of a cross-platform, cross-cloud, multi-cloud way of doing this. It looks like it's built on Terraform Cloud though. So again, very cool feature of Terraform Cloud. Honestly, I don't know why this isn't built into AWS or Azure or the other, or GCP. Anyway, this is a pretty useful feature for anybody doing lab work in any public cloud.
Right? Or Armon brought up his dev environment. He left the company 6 months.
No, don't foreshadow, Armon. Come on, man. Don't foreshadow, please. Use somebody else's name there, dude.
Months later, his dev environment's still running, right? And so you see these patterns over and over again, and a huge amount of this just turns into just wasted spend, right? And so the idea of ephemeral workspaces is now we can tag these different workspaces and basically auto-destroy them if they're not being used. So you might say, great, CI environment, it auto-destroys after 24 hours. Dev environment auto-destroys after a week. And now you can actually manage that in a much more dynamic way. So super excited. This feature is now going generally available. It was announced over the summer in beta. Next, I want to do a quick refresher on Terraform no-code modules. This builds on top of the ability to define modules with Terraform, where you're encapsulating a set of patterns so that your developers don't have to know low-level Terraform, right? You don't have to interact at the kind of raw Terraform resource level. Instead, you can package up a higher-level pattern and then expose that out. And so a developer can come in and say, great, I want to consume this.
So they're using this buzzword no-code, but essentially this is an infrastructure as code service catalog, which brilliant. I mean, I think that makes perfect sense for HashiCorp's product offering. At the conference, we saw them kind of tie a new version of Waypoint that tie these no-code modules or these modules exposed via service catalog into development workflows, which I think it's a very interesting idea. It's very different mechanics to how people typically work with Terraform today. So, very interesting to see how people are adopting this, how well people are adopting this. Because usually the archetype of Terraform developer, you don't want a GUI, right? But I think the idea is that, hey, we can let those folks that don't like GUIs stay in non-GUI land and code the stuff in HCL. But we can add a thin layer of connective tissue to expose it to teams that don't have any interest at all in learning HCL or integrating infrastructure as code practices into their solutions. And then we can implement these kind of golden roads, gold paved roads, to these app dev teams that just want to, pump out a .NET app or a Java app or a Python app, or API, probably an API, into their cloud. So, interesting, interesting to see if that persona, exists and if they attach onto this, this process and this workflow.
No-code modules take that a little bit further by allowing you to not actually have to write Terraform. You can kind of point and click, as you just saw, through a UI. And underneath, it's actually templating the right Terraform and invoking those modules for you. But it makes it a little bit simpler. Now, I think one of the asks we've heard over and over, though, is, great, I have 5,000 developers in my org. 1,000 of them know Terraform. Should I train the other 4,000? Should they even have to know what Terraform is?
Good Lord, if you have 1,000 Terraform developers in your org, you are doing fantastic. How about you? Do you have 1,000 Terraform developers in your organization? My experience, outside of Microsoft was it is very hard to find really, really well-skilled Terraform developers. So my God, please study for those exams. Please get your hands on Terraform and start doing stuff with it, because I would love to see more organizations with having the problem of 1,000 Terraform developers.
Right? Or is there a higher level way that I can expose this where they don't even have to come in and understand what Terraform is? So we've heard this enough times, and we've spent a lot of time thinking about, okay, what's that higher level abstraction? How do we move away from necessarily even having to think about low level infrastructure? And we're super excited to sort of bring
And that's it. That's pretty much it from a Terraform announcement standpoint. Big news is Terraform Stacks, of course, which sounds very compelling, very interesting, and really probably the biggest thing that's going to improve productivity for folks like me on a day-to-day basis. Terraform Test, of course, was announced before the conference, but really excited to see more about Terraform Stacks. I'm going to talk more about it on my channel, and think about how Terraform Stacks is going to affect the world of Terraform going forward. More to come on that in future videos. If you enjoyed this video, please smash that like and consider subscribing to my channel. I enjoyed my time at HashiConf. It was a great time. I really appreciated being there, putting a lot of faces to names and connecting with the broader infrastructure as code community at Microsoft. And just had a really good time. It's always a good time visiting HashiConf in San Francisco. Next year it's going to be in Boston. Let's see if I get to go. That will be a lot of fun. But a lot more content to talk through about what I learned at HashiConf. So stay tuned and keep terraforming Azure. This is the Azure Terraformer signing off.